All right, Algebra 1, we're going to go ahead and go forward and go to Lesson 11-2, Operations with Radical Functions. So we're going to be adding, subtracting, multiplying, and dividing, okay, using our radicals and combining like terms and so forth. So when you are adding or subtracting your radical functions, they have to have like radicals. Okay, so like radicals. So I notice like this one here is a root 6. That one's a root 6. I can go ahead and add these two. Or subtract these two, sorry. So what's 2 minus 3? Negative 1. So I would write that as negative 1 root 6. Notice I did not add my root 6. I didn't make it root 12. You combine just exactly as it is. So you combine with just it being root 6. Just like what we did with x's. You combine your like terms. Okay, so done. Okay, when you get down to problems like these. Now I'm looking, I don't have like radicals, but I know I can simplify this. So over here I wrote again my perfect squares. So I've got 4, 9, 16. Which one of those, which you should be good at now, goes into 12? 4. So I am going to rewrite this as 2 root 4 root 3 to break that down, minus, I'm not doing anything with that one. I leave it as 7 root 3. Well, what's the square root of 4? 2. Well, what's 2 times 2? So basically, let me write this out. It would be 2 root 3 minus 7 root 3. So I'm going to come on up here. So 2 times 2 is 4. So now I have 4 root 3 minus 7 root 3. Now I can combine my like terms. So what's 4 minus 7? Negative 3 root 3. Done. This one here, same thing. I can't break that one down further, but I know I can break this down, and the perfect square that goes into 45 is 9. Goes in 5 times. So I'm going to rewrite this as 4 root 5 plus 2. I'm going to put my brackets. Root 9 root 5. Well, what's the square root of 9? 3. So I got 4 root 5 times plus 2 times 3 root 5. Well, what's 2 times 3? 6. What's 4 plus 6? 10. My answer is 10 root 5. So pretty simple when you're dealing with the adding and subtracting. You just have to make sure if there's like radicals. And if there's no way that they can have like radicals, or that there is no like radicals, then leave it big. So if this would have been a 7, for instance, I would have just left it 2 root 6 minus 3 root 7. Okay, multiplying. So this one here, distributive property. So I'm going to take root 3 times root 27, which is root 81. What's root 3 times 1? Root 3. Well, what's the square root of 81? 9. I can't go any further. There's nothing more left for me to combine. So I leave it as 9 plus root 3. So with those, you just distribute through, and you just multiply it all the way through. Okay? So over here, we're going to FOIL. First, outside, inside, last. So my first, what's 4 times 9? 36. What's 4 times root 13? 4 root 13. What's 9 times negative root 13? Negative 9 root 13. Root 13 times root 13, guess what that is? Just 13. I'm going to put a little side note up here. It was the square root of 169 if you wanted to put it. But remember, when I told you, when you have two radicals that are exactly the same and you're multiplying them together, the radicals disappear and you're left with just the number. So now let's combine like terms. What's 36 plus 13? 49. I can combine those two, and notice that root 13 is not, it's fully reduced. You don't have to reduce it any further. What's 4 minus 9? So I'm going to change that to a negative 5 root 13. Done. All right. Now we'll get into some of the more difficult ones, and these are the dividing ones. When you are dividing your radicals, you multiply what I call the complex conjugate, or the conjugate. What I mean by the conjugate of this problem right here would be root 10 plus root 5. I changed that sign in the middle. I'm going to put parentheses around this denominator. Root 10 plus root 5. Okay, all I did is I just changed the sign in the middle. So if this would have been positive, what would I have changed it to? A negative. So now this one here, I'm going to distribute through. So 3 times root 10, I'm going to leave it as 3 root 10. Plus 3 times root 5, we leave it as 3 root 5. And one thing I always tell people when we're multiplying these, real to real, radical to radical. Okay, so if this would have been root 3, now I would have multiplied it into those radicals. Okay, but since it's a real part, it just goes out in front of those radicals. Over root 10 times root 10, here's another one. They're exactly the same. So it's just 10. This right here is going to be root 50. Well, what's this going to be? Negative root 50. So I'm going to have a positive root 50. I better write it out. Negative root 50. What's negative 5 times, or negative root 5 times root 5? Negative 5. What happens right here to those 50s? Goodbye. So up top, my numerator, I'm left with 3 root 10 plus 3 root 5. My denominator, what's 10 minus 5? 5. I am done. I no longer have that radical in the denominator. Okay, so I am done. Last one. I can reduce this, so I'm going to. So I'm going to write this as 12 over square root of 8. You should already know by now is 2 root 2. That's going to be a common one you're going to have, because this is square root of 4, square root of 2, 2 root 2. What's 2 root 2 minus root 2? 1 root 2. So I'm going to rewrite this as 12 over root 2. Remember, we can't have a radical in the denominator. Multiply by root 2 over root 2. 12 times root 2 is 12 root 2. Again, I got two radicals the same. It's 2. 2 goes into 12 6 times. My answer for that one is 6 root 2. Okay, so on some of those, if you can simplify that denominator and see that they're going to have common terms, do so. And what I did with all of these examples, I did an example of each type of problem you're going to encounter. Okay, so there's an example of every single problem you're going to encounter in your homework. So make sure you're looking back, rewatching the videos, rewinding, all of that good stuff to help you through some of those problems. You'll see a lot of these were the odd problems from this lesson that you guys are going to be doing today. All right, so there it is, operations with radicals. You know how to get a hold of me if you have questions, guys.